As your business changes, an ordinary computer may not support your demands. You need a computer that was designed for change. An IBM PS2. When you shuffle things around, you can easily add advanced cards for complex imaging, networking, multimedia, and more. So instead of an ordinary computer, to play your cards right, how are you going to do it? PS2IT.
Hi, my name's Craig Allen. I'm an engineer with IBM Australia, and I've been working with IBM for about 6 years now, helping IBM's customers with the IBM PS2 product range. I'd like to take a moment of your time now to go through the IBM PS2 product range and help you make a decision on your personal computer acquisitions in the future. During this presentation, we will cover 6 basic areas. The first one is, what makes IBM unique in the personal computer industry? The next one is the cost of computing. Many people believe that the personal computer quote that they see on their desk when they're making an acquisition is the only cost associated with personal computer acquisitions. The next subject is very important considering the number of announcements that have come up this year. It's operating systems. We're going to cover DOS, some DOS extenders such as Windows, operating system version 1.x, and have a quick glance at operating system version 2, which I'm sure will excite you as much as it excited me over the last couple of weeks. The next one is bus design. Bus design plays an important factor in the type of personal computer you're going to be buying for today and for the future. There are many different types of buses available on the market, but only one bus will take you into the 1990s. The last section is probably the most interesting. It's called the IBM PS2 Strip Show, and I'm sure you'll get as much out of it as I will. First of all, in the personal computer industry today, what makes IBM unique? IBM has a very extensive product range. We sell everything from the IBM laptop, what we call the baby blue, up to the fastest and most powerful personal computer available on the market today. In fact, just 3 weeks ago, we announced the 50 MHz 486 version of our Model 90. We also implement leading-edge technology. Things such as the 8 megabit chip, the optical read-writable CD-ROM, the microchannel architecture, and all of these things put together allows you, the customer, to take advantage of tomorrow's technology today. We also have a very extensive range of business partners, from the IBM PS2 authorized dealers to value-added resellers to marketing channels and marketing contractors, and we have a very large number of associations with other computer vendors and manufacturers. Some of the more interesting ones to pop up in the press just recently is our talking to Apple computers. Now, there are advantages for you as a user. IBM and Apple will be converging their operating systems, their interfaces, and even their processor platforms in the future. Some other interesting associations are with Novell Netware, are with Lotus Development Corporation, and a very interesting one with Borland on future C language announcements. IBM Australia consists of 4,700 people who are all out there to serve you, the customer. Every one of those IBMers can be called up over the phone and we will get the job done for you. The last, and not the least important, is IBM Link. If you are a customer of IBM, then you can get access 24 hours a day to IBM. We have a facility called IBM Link. With a personal computer, a modem, and a telephone call, you can call up IBM and get access to our entire databases, such as question and answer databases, what education is available, and book yourself on the education, what manuals are available. And if you want to set up a relationship with any particular IBMer, we can even set up electronic mail to his user IDs. These are some of the basic differences which makes IBM unique in the personal computer market today. An interesting report came out in 1988 called the Nolan Norton Report. And basically, to summarize a very lengthy document, they came up with the conclusion that the hardware and software costs of personal computer acquisitions is only 28% of the entire costs. The other 72% consists of training, downtime, service costs, maintenance fees, and other costs which are not entirely evident when you actually make your personal computer acquisition. Some of the things that should be considered: ease of use. From a hardware and software point of view, we'll be showing you the software side with OS2 version 2, and we'll be showing you the hardware in the IBM PS2 strip show. One must also consider reliability. You must remember that you're running a business on the personal computer. Can you really afford to have the personal computer break down even once? And this leads us to quality. IBM has one of the highest ratings of quality in the personal computer industry. In fact, the manufacturing plant down in IBM Wangaratta has the highest quality standard of any IBM PC manufacturing plant in the world. So, you may be able to save 50% on the 28% of hardware and software costs, but you're going to lose out in other areas, such as service, support, reliability, and most important, quality. That's why IBM's cost of computing is not always considered in the full context. This is why we recommend to our customers to implement a corporate strategy. A corporate strategy consists of 5 basic areas. Acquisition. You need to know which supplier you're going to for your PCs, so you can take advantage of any price discounting that may be going on. You also need to be able to administer the personal computer acquisitions, being able to tell where they're being installed, being able to have information centers so users with problems can call up and get support within your own company, or being able to get hold of IBM in a timely fashion. The next section is training and support. They basically go hand in hand, because the best type of personal computer acquisition is one where you don't need any external resources for support. That's why we recommend our customers are fully trained on personal computers before we let them use it. Support also plays an important factor. You may need some high-level support from some of our advanced system divisions associated with our dealers, or some engineers from IBM. The second last bit is integration. It's no use having a personal computer if it won't talk to anything. We've moved away from the environment where personal computers are islands of information. We are now into high-speed LAN networks, communications with mid-range and mainframe systems, making the personal computer a very powerful business tool. And the last one is control. You are maintaining your corporate data on those PCs. You need to be able to implement security measures and find out who is using computers at any point in time. Other things such as stock takes. IBM has placed the serial number of each IBM PS2 on the front of the machine. So doing a stock take is now far easier than it has been in the past. We recommend a corporate strategy to save you time and money, because coming down the end of the track, you don't want to end up with a whole lot of useless equipment. Now we'll move into operating systems. This plays an important role on what type of computer you'll be buying in the future. In the past, the operating system of the industry has been DOS, and many say it still is today. But nobody can tell me that people aren't looking for extenders to the true DOS environment. And this is one of the major reasons for this is what we call the RAM cram. DOS has only 640 kilobytes of memory, and that's all it'll ever be able to have, or will it? I'll show you something that will change your mind in the next section of operating system 2. Next one is memory management. We've seen a lot of band-aid solutions in the industry with things like XMS, EMS, DPMI, where you can address megabytes of memory. But can you really address that memory? Most of that memory is only addressable by data. You cannot run executable code in that higher memory spaces. Next one is task switching. On average, people have 1.6 applications per PC. This means that whenever you want to use the other application, the 0.6 of an application, You have to get out of your original application, get into DOS, and start up the new application, and vice versa. Now that we've implemented task switching and multitasking in Operating System 2, you can switch between applications much quicker. It is an environment that requires minimal hardware. But in these days and times, what is minimal hardware? The average IBM workstation consists of an Intel 386SX running at 20 megahertz with 2 to 4 megabytes of memory. This is more than enough to run Operating System 2. DOS is lucky in that it has a wide range of applications, off-the-shelf applications which the user can use almost straight away. But we're now seeing a wide range of applications being moved into the OS2 environment. And the reason for this is the applications these days have to be easier to use. When an application is easier to use, you require far more code. When you have far more code, you use up far more memory. And DOS is unable to cope with these additional memory requirements. That's why we're seeing more and more applications being moved to other operating system platforms. And we've seen many DOS extenders in the market. The flavour of the month at this point in time is Windows 3, and it is a very valuable tool as a DOS extender. The ability to address additional memory, being able to have task switching between applications, communications and the like. But we must remember that Windows still inherits all of the flaws of DOS because it is running on DOS. The next operating system is what I believe will make a change in the 90s. Operating System 2 is a new operating system. People say it doesn't have any applications. I can't run it on anything. But Operating System 2 has only been around for 3 years. Things like DOS have been around for 10 years. Windows itself has been around for 5 years. Unix has been around for many, many years now. As far as Operating System 2 goes, it's actually at maintaining market share quite dramatically. Not as good as DOS, but a lot better than Windows. We'll also see with the new release of OS2, called OS2 version 2, multiple DOS, what we call multiple virtual DOS machines. This means that I can run up to 256 DOS applications at exactly the same time in a full multitasking environment. Much larger memory support, and I'll be showing you this not only for DOS but also for OS2. Multitasking. OS2 gives you the ability to multitask. Now in the past, with the DOS environment, you could only single task. With OS2, you can actually start up an application, such as a Lotus spreadsheet, let it go through a calculation stage, and do something at exactly the same time. Another example, and this is my favorite, is formatting a diskette. How many times have you formatted a diskette under DOS? What's the next thing you do? You head towards the coffee machine. Under OS2, you can format a diskette and still be doing that Lotus recalc. One of the other important considerations with Operating System 2 is what processor will it run on in the future. IBM and Microsoft are presently working on a new version of OS2 which will allow it to run on RISC-based processors. So you will see a migration from Intel to other types of processors. RISC stands for Reduced Instruction Set Computing. Basically, a RISC processor can give you far more power for less bucks. OS2 also gives you online documentation. In the past, if you wanted to learn the parameters for a particular command, you would pick up your DOS manual, go to the index, find out the multiple entries in the manual and cross-reference between those entries. In OS2, you have the online command reference. By simply double-clicking on this icon, you can then do a search on, say, the format command and find out what the parameter it is for formatting a 720K diskette as opposed to 1.4 meg diskette. With OS2 version 2, you'll also see a change in IBM. We'll be actually adding something that's useful. Tools, utilities and games. You'll see Tetris, even Solitaire available from IBM. We believe that tools and games help the user become familiar with the operating system. and therefore we recommend that you should play some games when you first install OS2. This all brings us to the final point. DOS really has reached the limitations of its internal design. OS2 is the successor to DOS. OS2 is the operating system for the 90s. What I'd like to do now is take you through a quick demonstration of OS2 version 2. This version of OS2 should be available in the November timeframe. Some of the more exciting things about OS2 version 2 is what it can do with DOS. For example, we now support what we call multiple virtual DOS systems. This enables us to run up to 256 versions of DOS on the machine at exactly the same time. We can also run them in a windowed environment and in a full screen environment. But one of the more exciting parts I'd like to show you is the memory available under DOS. First of all, I'll show you DOS as it is shipped with the OS2 version 2. And as you can see, I'm running DOS in a windowed environment. If I run a check disk command now, we can see how much memory is available. And surprise, 640K is actually available for application space. But with the multiple settings I can use for the DOS environment, I can actually do things like restrict the video mode. And what I've done with this copy of DOS is actually restricted to CGA only. Most applications, such as Lotus, only use the CGA spec. So let's see what happens now when we run the check disk command. 740K is available for DOS applications. Considering that we can run the DOS application in 740K, plus have 32 megabyte of extended memory and 32 megabytes of expanded memory, this certainly makes OS2 a DOS better than DOS. Another thing that we'll be making available with OS2 version 2 at general availability is the Windows kernel. This means that you will be able to run all of your Windows applications under OS2 version 2. You'll also be able to run multiple copies of Windows at the same time. This makes OS2 a Windows environment better than Windows. The other interface, which is more exciting, is called the SAA Workplace. The SAA Workplace allows you to incorporate Presentation Manager in an environment which is very similar to the Macintosh. We implement things like drag and drop and folder type operations. All of this is available with OS2 version 2 and should be available to you as a customer around about the fourth quarter time frame. Just as an aside, we have also included a number of tools and games. The first thing you'll notice when you open up the tools is the enhanced editor. And believe me, this is enhanced over Edlin, and in particular the system editor associated with the original copy version of OS2 version 1.x. It comes up as a small book icon. On clicking on the book icon, I bring up a dialog box and I can see all of the files which can be edited after that point. By going back, we can have a look at the config.sys, and you can have a look at the editor in its full glory. We can also change fonts and have multiple documents open at exactly the same time. Another nice feature is with OS2 version 2, we are shipping what we call applets. You will probably call them games. You'll notice Solitaire, a very important application if you want to use an operating system. We also have a version of Tetris running under OS2 and a couple of other nice features, such as the lock-up keyboard and mouse, which gives you an added security to your environment. There's also another one called the Jigsaw. You can take any OS2 bitmap or Windows bitmap and create a jigsaw with it and then be able to put it back together on the screen. So this was a quick demonstration of OS2 version 2. If you want to see more about OS2 version 2, then ask your local IBM representative for a copy of what we call the Blue Ninja tape. It's a 50-minute tape by Lee Reiswig and will certainly turn you on with OS2 version 2. I hope you're as excited about OS2 as I've been playing with it over the last couple of weeks. Remember back in 1981 when IBM introduced the IBM PC1? That was 10 years ago now, but the IBM PC1 has revolutionized the personal computing industry. In today's times, though, the IBM PC1 really doesn't hack it. It's a very old architecture. In fact, it's 10 years old this year. It's also a very slow architecture. The IBM PC1 ran at 4.7 megahertz, and that's the slowest there is. It's also a very cheap architecture. You can go out and buy an IBM PC1 original or a clone for about $500 on the market today. But considering the age and the technology of this particular design, there really isn't any future for the IBM PC1. The IBM PC1 bus design is a very simple bus design. It consists of an 8088 Intel processor running on an 8-bit bus. On the bus, we then attach the adapter cards. But the key to this is that the 8088 processor is in full control of the bus. This means that the IBM PC bus is totally dependent on the Intel processor. In 1984, IBM came out with a new PC called the IBM AT. It was an enhancement of the PC1. The enhancement basically consisted of a 16-bit extension. The IBM AT could now run 8 and 16-bit adapter cards. But it wasn't for many years after the original announcement that we started shipping adapter cards which took advantage of this 16-bit bus architecture. The original speed of the IBM AT was 6 and then further extended to 8 megahertz. Once again, this bus is totally dependent on the Intel 80286 chip. So what we see is the Intel 80286 chip, the AT bus architecture running at 8 and 16 bits. At about this time, IBM announced a new bus architecture called microchannel. But before we look at microchannel architecture, let's have a look at what the competition came up with. In the design labs, IBM actually had an extension to the original IBM AT bus architecture, similar to what is offered in the ESA consortium. ESA stands for Extended Industry Standard Architecture. The ESA consortium consists of 7 clone manufacturers who've come up with a bus design to compete with the microchannel architecture. But there are some inherent drawbacks to the ESA design. First of all, it is an enhanced PC, enhanced AT bus architecture. It is a very complex architecture for this exact same reason, supporting 8, 16 and 32-bit devices on a single bus. This makes it very expensive. For example, the entry-level ESA-based machine costs around about $15,000, while on the other hand, IBM's microchannel entry-level point is around about $4,000. There are very few ESA adapter cards to take advantage of the ESA bus architecture. Once again, because it is an enhancement of the AT bus architecture, it must have an Intel processor on the bus, so it is Intel specific. Because 7 clone manufacturers came together to build this single architecture, there is in fact no one standard. In every one of the ESA-based machines, there is a particular component called the CPU memory complex, which is specific to each individual ESA machine. This enables the ESA consortium to be able to differentiate themselves. Now, as you can see, the ESA bus, or the ESA design, is actually a very complex design. Down the bottom here we have the ISA bus for the original 8 and 16-bit bus cards, and not all AT adapter cards are actually compatible with this part of the bus. Up the top here we have the ESA bus, the 32-bit part of the bus. And as I said before, there aren't actually all that many ESA bus cards to take advantage of this particular style of machine. We have the CPU memory complex, and we have another bus down here called the I/O bus, which is used for keyboards and mouse ports. But the inherent flaw in this particular design is what we call the EBC, the ESA bus controller. This is actually a bottleneck in the entire system, because if an AT bus adapter card wants to talk to an ESA bus adapter card, it has to go through the ESA bus controller. We also have to have conversion of 32-bit to 16-bit. We have cards running down here at 8 megahertz, while up here they can be running at 20 megahertz. So you can see there is a bottleneck here right in the middle of the ESA bus. IBM back in 1987 announced the IBM microchannel architecture. Yes, we threw out all of the old design specs because they are limited, because they are very complex, because there is no one standard. And we came up with the IBM PS2. The IBM PS2 and the microchannel bus architecture offers us a far wider implementation. For example, we have implemented microchannel architecture in not only the PS2, but the RS6000, a Unix-style machine, and an IBM mainframe. We actually have an entry-level IBM mainframe running on microchannel architecture. This infers that the microchannel architecture is processor independent. We've already demonstrated with the RS6000 processor and the 370 processor. But there are many other types of processors that you can place on the microchannel architecture and run many different types of operating systems. The microchannel architecture is also multi-processor. We can have up to 16 different processors running on the microchannel bus simultaneously. This also infers that the bus architecture is multitasking. In the heyday of the IBM PC-1, we had an operating system called DOS. DOS is a single tasking operating system. But now with operating systems such as Unix, OS/2, AIX, and the 370 environment, we need a multitasking bus architecture. A microchannel delivers. It also is very cost effective. As I said before, an entry-level point for microchannel architecture is $4,000. This means you can implement one architecture through your corporate strategies on the entire range of personal computer requirements. The savings, one standard, one set of adapter cards, one set of support. The microchannel architecture is truly designed for the 1990s. The microchannel architecture offers you simplicity in the design. It is a single bus, and as you can see, totally processor independent. Microchannel architecture is designed to take advantage of the 32-bit world, which is what we're entering into today with the 80386DX, the 80486, and you never know, the 586 is probably just around the corner. Now that we've got down to the actual bus architecture and moved inside the IBM PC, let's have a further look. I'd like to take you through what we call the IBM PS2 strip show. And now we come to the most exciting part of this presentation, called the IBM PS2 strip show. What we're going to do is take you inside the world of the IBM PS2. Here I have a Model 70, a 386 desktop machine. But one of the most interesting machines about all of the IBM PS2s are that they are manufactured here in Australia. In fact, they're the only PC range with the Australian-made certification. To get Australian-made certification, you need to have at least 80% of your components and sourced or manufactured here in Australia. So let's have a look at this IBM PS2 Model 70. First thing to notice is you need no tools to pull the machine apart. Now, we haven't forgotten about security. On the back of the machine we have a key lock which holds the chassis to the cover. We've also implemented a power-on password, so no user can actually access the operating system without it knowing the password. this can be optionally installed with the reference diskette. So let's take the cover off this machine by undoing the two screws here at the back here and have a look at the design. The first thing you notice about the IBM PS2 is the clean lines and the modularity of the design. You see that all of the components are in individual spaces. On the front here, we see the diskette drive, and this can be removed and replaced in under 30 seconds. Now, on the average clone, you will have up to 10 screws before you can actually remove the diskette drive and then put it back in place. This is the latest in technology, a 3.5-inch diskette format. IBM has recently announced a 2.8 megabyte format of the same diskette, which is available in the latest IBM PS2 range. We also have the disk drive, which can be removed as such. This is the latest in IBM hard disk technology. It's a 3.5-inch form factor with an SD controller built into the unit, so that when we replace a disk drive, we replace the controller card and the disk drive at exactly the same time. This particular drive has a 17.5 millisecond seek and is an SD controller. Under the speaker, we find a small plastic device. This is used for unclipping all of the plastic pieces. You can also use your hands. On removing the chassis, we lay bare the planar board. But the things to notice about the chassis are the speaker and the battery come with the chassis. These can also be removed. We also see the solid-state connections between the diskette drives and the hard disk. The reason we use solid-state connections is because this allows us to remove a lot of the ribbon technology, which is a point of faults in most personal computers. Now we come to the most interesting part. This is the planar board of the IBM PS2. And as you can see, for a 386 based machine, it's actually quite small. First thing you notice is the 386 processor from Intel running at 20 megahertz. We also have models in 16, 20 and 25 megahertz. The coprocessor slot for the 80387. Over here you see the latest in IBM's very large scale integration, VLSI. This single chip is actually the video subsystem for the VGA screen. Around it you see the memory associated with the video subsystem. We have the microchannel ports, full 32-bit implementation for the latest in technology. IBM is also at the forefront of research and development with memory technology. And this is a good example. Do you remember what 64K used to look like? There we have 2 megabytes of RAM. As you can see from this machine, we can actually install 6 megabytes on the planar board at any point in time. But we go beyond this. IBM has also developed and shipped 4 megabit and 8 megabit chips, which means that we can build a similarly sized SIM, single inline memory module, which has 8 megabytes of memory on it. Now we come back to the planar board. Some other unique features with the IBM PS2 range are here. These black things are surge suppressors. What they do is if you are connected into an external I/O device, such as a telephone, a printer, or the like, and you get a spike through that line, it will protect the planar board. For example, if you're dialing into the office and you get a lightning strike on the telephone line, you will actually protect the planar board, depending on where the lightning strike is. The other piece is the power unit itself. The power unit is almost unique. For example, it doesn't matter which voltage you plug it into, it will detect the voltage and automatically work. This means that if you plug it into an American outlet, a European outlet, an Australian outlet, or a Japanese outlet, it will still work without making any modifications to the machine. But there are some other unique features. This particular power unit can take brownouts and surges of 100 volts in either direction. This is particularly important with remote areas such as country towns and places in Western Australia. For this feature alone, this machine has actually sold quite well in the mining industry in Western Australia. That's really all there is inside an IBM PS2. As you can see, simplicity is the answer to delivering new technology. That's the IBM PS2 from the inside. And believe me, when we put this back together, it will still work.
5, 4, 3, 2, 1.
Well, as you can see, it really is a snap to put back together. I hope you've enjoyed this insight into the IBM PS2 range, and you're as excited about the product as I am.
An IBM PS2 with microchannel can add full motion video and stereo sound to text and graphics. So from classrooms to boardrooms, anything you create can be a multimedia experience that's truly moving. To get more impact, how are you going to do it? PS2IT.